Hi there, my name is Yasmin and I am a tutor here at Tutor Impact. And today we're going to be looking at the life cycle of a star. Now, you might not know it already, but stars have different stages in their life, and we're going to be looking at those different stages today. Now, the first question you might be asking is, what is a star? I hope you're already pretty familiar with the sort of concept of a star. We see them on most nights up in the sky as twinkling sort of dots in the sky. They're also the topic of poems, stories, nursery rhymes alike, but what actually are they in a scientific sense? Now, from a scientific point of view, a star is actually a luminous ball of gas, and this is comprised mostly of hydrogen and helium, which are elements, and these elements are held together by their own gravity. Now, you might not think it, but the sun that we see every day in the sky, that's in our solar system, that is actually a star, and it's actually our closest star to the Earth. So the sun, as I said, that we see every day, that is in fact a star. And the reason why we see it all the time is because it is so close to us. And we can see that day to day without having to use a telescope like we do for other stars. Now, according to current star formation theory, stars are actually born as clumps within a gigantic gas cloud that collapse in on themselves. And then the cloud's material heats up as it falls inwards under the force of its own gravity. Now, don't worry if that's quite complex for you, because we're going to break that down and look at this formation in the individual stages. So you can now see on my screen the overview of the life cycle of a star. You'll see that the cycle for a star depends on its size, and that's shown here by the two branches once we reach the main sequence star level. So this diagram here shows the life cycles of stars that are, one, about the same size as the sun, and two, that stars that are far greater than the sun in size. Now, you'll also see from the diagram that all stars begin life in the same way. So you can see that from this sort of the start of this cycle with protostar, then main sequence star. Now, all stars start with a cloud of dust and gas, and this is known as a nebula. So it's sort of the pre-stage before the protostar. It's not included on this diagram, but we will go on to discuss this in a bit more detail shortly. So after a nebula, it then becomes the protostar, which then goes on to become a main sequence star. And then following this, as I said, this is where the stars, the development of the stars sort of branches out depending on their size. So as you can see from the diagram, stars that are about the same size as the sun, they follow this left-hand path. So they go to a red giant star, and then they go to a white dwarf star, then they finally end becoming a black dwarf. And in contrast to that, stars that are much bigger than the sun in mass, they follow this right-hand path. So they go to red supergiant star, which we have on the right-hand side. They then become a supernova, which again, we will go on to discuss in a second. And then they have two options. Again, depending on their size, they can become a black hole or a neutron star. So the stars that are much bigger than the sun also have another sub sort of division of stages, and that is at the end between a black hole and a neutron star. But we will discuss this in turn. So now we're going to move on, as I said, to look at each one of these stages. And we're going to begin with Nebula, which, as I said before, was the sort of pre-stage to protostar. So we're going to start at the top and work our way down this diagram. So, as I said, we're starting with the nebula. Now, the nebula is, as I said, the pre-stage before a star becomes a protostar. And it's sort of the beginning process where a star forms from massive clouds of dust and gas in space, which is called the nebula. A nebula are most commonly composed of the element hydrogen. And gravity begins to pull this dust and gas together. So you can sort of see this in the second photo here. So there's a massive cloud of dust and gas in space, and then it starts being drawn together by gravity. And you can see that in that bottom diagram here as the star is starting to form. Now, we're then going to move on to the first stage of the diagram from before, which is the protostar. So you can see here a protostar in the diagram. So as that mass that we've just spoken about, all that gas and dust, as it falls together, it gets hot, so the temperature significantly increases. And the star is formed when it is hot enough for the hydrogen nuclei to fuse together to make helium. Now, we're not going to go into too much of the chemistry behind that process, but basically the hydrogen becomes helium. And this fusion process releases a lot of energy, which keeps the core of the star really, really hot. So as you can see in the diagram here, all of those gases are coming together, and we're seeing sort of the beginning stages of what we know as a star. Now, after the protostar stage, we have a main sequence star, which is the one that our current sun is in. So during this more stable phase in the life of the star, the force of gravity holding the star together is balanced by higher pressure due to the high temperatures. So for most of its lifetime, a star is in this main sequence phase. So this takes up the bulk of the life cycle of the star. And at this time, it is stable with balanced forces keeping it the same size all the time. During this period, gravitational attraction tends to collapse the star, radiation pressure from the fusion reaction tends to expand the star, and so these forces caused by gravitational attraction and fusion energy are balanced. So again, we're not going to go into too much detail on these forces, but all you need to know is we have the gravitational attraction on one side that's trying to collapse the star, and we have the radiation pressure from the fusion reactions trying to expand the star. And what this does is they sort of cancel each other out, meaning that the forces are balanced, which is what causes the star at this stage to be stable. Now, our sun that we see in the sky, the one in our solar system, it's at this stable phase in its life. And it's expected to be a main sequence star for billions of years. So our sun is going to be in a stable position for a long time yet. So it's not going anywhere. And as I said before, the main sequence is the main, that takes up the bulk of a life cycle of a star. Now, after the main sequence star, you'll remember it then splits, and we have a red giant star and a red supergiant star. However, the red giants are basically the same sort of thing, they're just different sizes. So even though it branches out at this stage, they're still both red giants. And this is when all of the hydrogen has been used up in the fusion process, and then larger nuclei begin to form, and the star may expand to become a red giant. Now, again, this is quite confusing, but all you need to know is that the fusion process has ended because the hydrogen has all been used up, and the star starts to expand to become a red giant. So this is the end of sort of the stable stage of the star's life. So we go from having those balanced forces when it's a main sequence star, and then now it becomes unstable because one of those forces, the fusion process, has stopped. So the forces are no longer balanced, and we have a red giant star. Now, you remember the smaller stars that are the same size as the sun or less, they then become a white dwarf. So we're going down that left-hand side first of the original diagram. So then they become a white dwarf. And this is when all of the nuclear reactions are over. A small star like the sun, it then may begin to contract under the pull of gravity. In this instance, the star becomes a white dwarf, which fades and changes color as it cools. So that original high temperature, which we discussed before, that decreases, and we have a much cooler phase of this star's life, and it becomes a white dwarf, which, as I said, it's when it fades and the color changes as it cools. Now, in contrast to that, you remember that on the right-hand side of this stage, the red giant star, when it's a larger star, becomes a supernova. So if you remember, we've gone from the red giant stage on this right-hand side to the supernova stage. And what this means is that a larger star, so a star that's larger than the sun, for example, it has more mass, so it will keep on making nuclear reactions. So in contrast to the white dwarf, which we just discussed, where the nuclear reactions have stopped, the larger star will go on to make further nuclear reactions. And this means it will get hotter and hotter, and it will expand more and more until it eventually explodes as a supernova. And when it does explode, it throws hot gas into space. So the star, it gets hotter and hotter and starts to expand until it explodes. And this results in the throwing of hot gas into space, which you can see demonstrated by this diagram at the bottom here. So it starts as a red giant, and then it expands and explodes and distributes all of this hot gas into space. So when the supernova does explode, all of these elements produced are thrown out into the universe. And heavy elements found on the Earth, such as gold, they've come from material being thrown out of previous supernova explosions. So most of the elements on Earth have been found from these explosions, these supernova explosions. Now, you remember as well that after the supernova, we then had the neutron star or the black hole. So this is the end of the life cycle for that right-hand side for the bigger stars. And the way whether it goes to a black hole or a neutron star, this really depends on the mass at the start of its life. And as I said, the supernova will either leave behind a neutron star or the black hole. So that is the end of that right-hand side column. We're now just going to go on to recap the stages that we have discussed about so far alongside the diagram. So you will see again from the beginning, we have the protostar on this diagram, but as you will remember, we also discussed the nebula, which is when the gas cloud of dust and gas in space starts to form. You'll remember that gravity slowly begins to bring all of that dust and gas together. And then we will have the protostar, and this is where the mass falls together and it gets hotter, so that temperature is increasing. And this star is formed when it's hot enough for the hydrogen nuclei to turn into helium. So we spoke briefly about fusion. As I said, you don't need to know too much detail about that process, but all you need to know is that the protostar forms once it's hot enough for the hydrogen to fuse into helium. And this fusion process, as we discussed, releases energy, which keeps the core of that star hot. Now, after the protostar, we move on to this main sequence star. And as we discussed, this is the most stable phase in the life of a star. And it's the current phase that our sun in our solar system is in. And it's, as I said, for most of its lifetime, a star is in this main sequence phase. And during this phase, we have balanced forces. So as we discuss later on, the forces become imbalanced, which is why the star changes into the different types. But at this stage, all of the forces are balanced. So we have the gravitational attraction, which is trying to collapse the star, and we have the radiation pressure from the fusion reactions, which is trying to expand the star. And this expansion and collapsion, they're sort of competing against each other, and they balance out, which makes the star stable, as all the balanced forces are keeping it the same size over time. And as we said, our star is likely to stay in this stage, our sun, for billions of years. Now, once those forces are no longer balanced, so once one is bigger or smaller than the other, we then move on to the red giant stage. And as you can see, the red giants are both the same on either side, they're just different sizes. So a star becomes a red giant once all of the hydrogen has been used up in fusion, and we lose one of those balancing forces, which means that the fusion process ends and the star becomes to expand to become a red giant. And as I said, this stage is the same on both sides, it just depends on the size. However, the size then plays a factor when we move on to the next stage, because the smaller stars, like this, our sun, once the nuclear reactions are all over, they began to contract under the pull of gravity. And in this instance, the star becomes a white dwarf, which fades and the color changes as it cools. And then eventually it becomes the black dwarf, which we didn't really discuss, but it's just the end stage of this cycle as the color changes and fades. However, on the other side, for the larger stars, we then have the supernova stage, which is where the star carries on making these nuclear reactions and gets hotter and hotter until it eventually explodes. As we discussed, all the gas and the elements that are in that explosion then get scattered across the universe. And then the final stage in this right-hand side are the black hole and the neutron star. And which one the star becomes really depends on the mass of the star. Now that is the end of today's lesson. I really hope it's been useful for you and given you a good introduction into the life cycle of a star. As I said, there's a lot more to the chemical reactions that are going on in this process. And if it is something you're interested in, I would really recommend researching. But I hope this has piqued your interest and that you have found it helpful. Thank you for watching. Bye-bye.